Hey guys, we are going to be starting acids and bases, so I'm going to give you a kind of quick run through of general characteristics and properties of acids and bases, and then we'll move on from there. All right, so a couple of just properties you should be aware of is that weaker acids tend to have a sour taste. So if you think of citric acid in like oranges and lemons, or malic acid, which is in like warhead candy that gives it the sour taste on the outside, those are examples of weak acids. Characteristics properties of bases is bases tend to have a bitter taste, and they tend to feel slippery if they get on your hands. So I can usually tell immediately in the lab if I accidentally get the littlest bit of base in my fingers because it will feel slippery, almost like soap. And then I know I have to rinse it off immediately with water. Some general things with the pH scale. It's been probably a little while since some of you guys have seen that. The pH scale usually is considered going from about 0 or 1 to 14. So a pH of 7, keep in mind, is neutral. Anything that is less than 7 is considered acidic. Okay, the closer, lower number you get towards 1 or 0, the more acidic it is, the stronger the acid it is. For pH values for bases, this is going to be anything that's greater than 7. And the closer you get up to that number of 14 or even higher, the more basic it is, or the stronger the base it's going to be. So there's some general little things you need to keep track of. Acids and aqueous solutions of bases are both considered electrolytes, which we've talked about a little bit when we did bonding and properties of different types of compounds. Keep in mind that electrolytes are substances that can conduct an electric current once they've been dissolved. So a couple things is that the greater the concentration of the ions, the more mobile charged particles, so the greater the electrical conductivity. Also, the stronger the acid or base is, in terms of like a strong versus a weak acid or base, the more ions it's going to put into solution, so the better the conductor it will be as well. One thing to always check with acids and bases is table K and L. Anything on table K and L, which is a series of acids and bases that the reference tables give you, which I'll pull those up right now. Right here, those guys are going to be your electrolytes. Also keep in mind, just from previous units, that we also considered any ionic compound an electrolyte as well. All right, one thing that acids and bases kind of have in common with each other is that they can react together to form water and a salt. So this is kind of the general formula that you need to be aware of. The acid and base will produce water and a salt. And we'll get into later in this unit how acids can contribute hydroxide, Arrhenius bases contribute, the hydrogen ion or hydronium, bases contribute the hydroxide ion, and that's going to be able to produce our water when we get into the net reaction. One last property that is specific to acids has to do with how they react with metals. And if we were in the lab, we'd actually test out some different metals reacting with acid. So when metals react with acid, they will form hydrogen gas. And a salt. And salt is not just table salt, NaCl. It's going to be the positive negative ion that's going to form the ionic compound. So this is where table J is going to be really helpful. So I will pull that one up. So table J is the activity series. So you'll see we're going to be focusing in on our metals. So we have these guys. Ooh. Have your metals that we're going to be looking at. The most active metals are up at the top, and then as you go down the list, you get to the least active. And the one that we're concerned with right now is H2, or hydrogen gas. That decides what ion in our acid, or metal I should say, is going to be able to react to produce the hydrogen gas. So any metal located above H2 on table J is going to react to produce hydrogen gas and salt. However, and this is called a single replacement reaction. However, the three elements that fall below H2, copper, silver, and gold, are not reactive enough to react with the acid to produce hydrogen gas, so they will not occur. So that was copper, Cu, silver, Ag, and gold, Au. So these will not react with acids because they're located lower than H2 on table J. So they're not reactive enough to undergo that single replacement reaction. So when you see a single replacement reaction, you're going to first focus in on the metal. Okay, zinc is above H2. So that means that this reaction will occur. So the first thing we want to write is our H2, which is diatomic and a gas. And then we're going to look at our salts, would be our zinc, which on the periodic table is +2. The chloride ion is -1. So I'm going to need 1 +2 and 2 -1s in order to create a neutral formula compound. So I'm going to have zinc, ZmCl2. And if you were writing phases or including those, you would have them as aqueous. Okay. If we look at this next one, we're going to focus in on copper, which copper is one of the ones that we listed. It falls below H2 on table J, so that means copper will not be able to undergo this reaction with H2SO4 sulfuric acid. So for here, we would write no reaction. Okay, so it wouldn't produce hydrogen gas or a copper compound. All right, that's all you really need to know today. We will move on in our next lesson to defining Arrhenius acids and bases and going from there, but that's all you need for right now.